we need to understand something called the probability distribution. Now this probability distribution वाला जो portion है थोड़ा सा difficult लग सकता है, but it's very important in the sense that if you understand this portion, ultimately it will lead to normal distribution, and normal distribution you're going to need it right now and even at a higher level also. And normal distribution को लेकर के बहुत सारा sums है. So this topic eventually is going to lead to the normal distribution. So therefore make sure you're understanding this part very well. Otherwise ये सब चीज़ ना आप लोगों ने स्कूल में जो लोग 11-12 में था किया था. If you guys remember uniform, non-uniform distribution, even if you can just faintly recall the terms that have been discussed in 11-12. Although कोई फर्क नहीं पड़ने वाला है because स्कूल में you had to kind of maybe mug up, but अभी वैसा हम लोग को नहीं करना पड़ेगा. We'll just have a very clear understanding about these things. So first of all, what do you understand by a distribution and what do you understand by a probability distribution? What do you understand by a distribution and then probability distribution? If you guys remember, when we were discussing skewness, be very attentive, last में copy करवा दूंगा, so don't worry. ध्यान दो, बहुत ज़रूरी है. So when we were discussing skewness, we had discussed data points, we had discussed shape like these. ये negatively skewed था, ये अपना zero skewed था as in symmetrical data था, right? Over here we see that there is an equal probability of falling above or below the average. यहाँ पे we were looking at the mode over here, but the mean being stretched towards the left side. That is why we are also calling it the left skewed distribution. इसका ये distribution हो गया. अभी distribution क्या हुआ? We've already done distribution in a way. Distribution का मतलब क्या हुआ? When we are discussing these graphs, तब मैंने समझाया था आपको कि हम लोग क्या कर रहे हैं. Let's say for example, I've taken past data. मैंने 1000 days का रिटर्न कलेक्ट किया. वो 1000 days का रिटर्न इज रेंजिंग लेट्स से बिटवीन -4% एंड लेट्स से +16% also. Most of the values are arranged around the 8-9% range. We had also discussed taking that example, I believe, कि घर से आपको ऑफिस जाने में कितना टाइम लगेगा. तो most of the days you will take somewhere around 20-25 minutes. Less number of days you take very high amount of time, and very less number of days you take very low amount of time. Normally, normal distribution, I know I've not talked about normal distribution, we'll get to it, but normally what happens, most of the data should be around the average. Extreme values में data कमती होना चाहिए. We talked about merging statistics and probability together. So looking at the past observations, आज 1000 में से अगर 200 days में the data is over here, तो can I say that there is a 20% probability that the return is going to be 8%? So ये वाले एक्सिस पे क्या प्लॉट हो रहा है? फ्रीक्वेंसी. ये वाले एक्सिस पे क्या प्लॉट हो रहा है? डेटा. Another thing that I've seen students doing is, one तो मैंने आपको बताया था कि प्लीज टाइमलाइन बनाए बिना सम नहीं करना है टाइम वैल्यू ऑफ मनी क्वेश्चंस में. दूसरा, डिस्ट्रीब्यूशन बनाए बिना आप सम नहीं करोगे. वंस वी डू डिस्ट्रीब्यूशन एंड इट सम्स, यू विल गेट अ क्लैरिटी. थर्ड थिंग, आई हैव सीन स्टूडेंट्स दे इग्नोर एब्सोल्युटली कि एक्स एक्सिस में क्या है, वाई एक्सिस में क्या है. आप वो नहीं कर सकते. आई नो स्टूडेंट वो बोल देंगे कि ग्राफ इसका बॉन्ड का ग्राफ ऐसा होता है, लेकिन ऐसा ग्राफ में इधर क्या यू डोंट नो, देन व्हाट इज द सेंस ऑफ यू नोइंग द शेप? Are you understanding? So be very attentive. You cannot have a superfluous level of studying. I've seen a lot of people book के साथ बैठे हैं, ऊपर से पढ़ रहे हैं. ऊपर से पढ़ने से नहीं होगा. It might get you through maybe a level 1, may not be able to get you through a level 2. Even if it gets you through a level 1. So superfluous way में पढ़ाई नहीं करेंगे. So if there is a graph, you need to know what is the x-axis, what is the y-axis, what is the shape, why is the shape so called, right? एंड उसका टर्म्स का नाम क्यों है, नॉर्मल डिस्ट्रीब्यूशन क्यों. इसलिए मैं देखो बार बार बीच में लाइंस में बोलते जा रहा हूँ नॉर्मली डेटा ऐसा होता है, ताकि मैं बाद में कनेक्ट करके उसको नॉर्मल डिस्ट्रीब्यूशन बोलूँ. देयर इज अ लॉजिक बिहाइंड एवरीथिंग, राइट? इट इज पुलिंग द मीन टुवर्ड्स लेफ्ट, इट इज स्ट्रेच टुवर्ड्स द लेफ्ट, देयरफॉर लेफ्ट स्क्यू. सो एवरी नॉमेनक्लेचर, एवरी नेमिंग, एवरी टर्मिनोलॉजी हैज गॉट सम लॉजिक बिहाइंड इट. सो इफ यू स्टार्ट ग्रास्पिंग द लॉजिक, आपका मगिंग अप गया ना, क्योंकि आप तो टर्म से ही समझ जा रहे हो, टर्म के नाम से ही समझ जा रहे हो कि क्या चीज क्या है. Are you understanding? And please be with me in making your level, your base very strong, ताकि आगे बहुत easy हो जाएगा हम लोग के लिए काम. Are you understanding? It's not just for the current studying that you're doing all this, but also for later levels. What happens? It becomes very easy for you. So data इस तरीके से जो distributed है, ultimately you're taking frequency on this axis and you're spreading data across over here. मैं देख रहा हूँ कि 8% कितनी बार आया, 9% कितनी बार आया, 10% कितनी बार आया, 11% कितनी बार आया, 7% कितनी बार आया, 6% कितनी बार आया. Ultimately, what am I doing over here? I'm trying to form the distribution of the data. What do you understand by the distribution of the data? When we are talking about standard deviation and all, अपने क्या कर रहे थे कि on an average the data is like this and बाकी data उसके आसपास कैसे distributed है, dispersed है, क्या closely distributed है SD low, क्या दूर दूर distributed है SD high, क्या extreme outliers है negative या positive skewness, क्या more data आसपास mean के है platykurtic mesokurtic या more data in the tails है leptokurtic. So we were trying to understand how the data is distributed, and that's exactly what I'm going to plot over here on the graph. So therefore there's a distribution. And the moment I say frequency को 200 days divide by 1000 की जगह मैं 20%, 5% ऐसे भी तो कर सकता हूँ scale को. I can represent the scale in terms of percentage, right? This gives you a probability distribution. I'm assuming that whatever has been the frequencies and all in the past data, it represents the probability for the future. कि अगर पास डेटा में 1000 में से 200 डेज ऐसा हुआ तो फ्यूचर में भी आउट ऑफ 1000 डेज 200 डेज ऐसा होगा. दैट इज 20 on 100, दैट इज 20% टाइम्स दिस इज गोइंग टू हैपन. इज एवरीबडी कंफर्टेबल? एब्सोल्युटली श्योर. फॉलोइंग? सो दिस इज प्रोबेबिलिटी डिस्ट्रीब्यूशन. प्रोबेबिलिटी डिस्ट्रीब्यूशन से क्या समझ में आएगा? प्रोबेबिलिटी डिस्ट्रीब्यूशन से अंडरस्टैंड कि डेटा इज गोइंग टू बी डिस्ट्रीब्यूटेड किस तरीके से, प्रोबेबिलिटी इज मेकिंग फोरकास्ट्स. So the first thing, the first and the foremost thing of understanding probability is with respect to understanding to be able to make forecasts in the future. I'm understanding the distribution of the data and I'm looking at various points ka probabilities, percentages happening ka hone ka chances. We'll see how to interpret the distribution now. That is what we are trying to do in probability distribution. Let me give you an example जो मैं शायद 2 क्लास बाद कराऊंगा आपको. आज say for example, if I can say ये एरिया 95% है, मैं थोड़ा ज्यादा आगे लीप करा. आई एम टेलिंग यू द फाइनल आंसर व्हिच आई एम ट्राइंग टू रीच. एंड सपोज दिस इज लेट्स से 8% एंड 9.5% एंड 95% डेटा इसके बीच में लाई करता है. मतलब 95% रिटर्न्स ऑफ द स्टॉक इज लाइंग बिटवीन 8 and 9.5%. कैन आई नॉट मेक अ स्टेटमेंट कि आई एम 95% श्योर दैट द रिटर्न्स विल लाई बिटवीन 8 and 9.5%? ये हम लोग को करना है. ये 2 क्लास बाद आएगा. मतलब दिस इज द कंक्लूजन वी आर ट्राइंग टू रीच. Probability distribution पढ़ करके we are trying to reach this. You will not understand this right now. We'll need some time to get over here. But समझ में आ रहा है कि हम लोग का आउटपुट क्या है, हम लोग क्या करने का कोशिश कर रहे हैं. We are trying to understand, we are trying to make ranges, we are trying to make forecasts, and with probabilities we will be able to quantify the surety of that forecast. आसमान देख के बोल रहे हैं यार बारिश होने वाला है. That does not have any quantitativeness, attached to your certainty, your level of certainty. आप समझ रहे हो, बारिश होने वाला देख के बोल दिया ना. हाउ सर्टन आर यू, हाउ श्योर आर यू? सो आई कैन प्रॉब्ली अटैच, आई एम 95% श्योर द रिटर्न्स ऑफ द स्टॉक आर गोइंग टू बी बिटवीन 8 and 9.5%. आई विल बी एबल टू क्वांटिफाई माई फोरकास्ट्स. आई विल बी एबल टू क्वांटिफाई माई फोरकास्ट, क्वांटिफाई माई सर्टनटी ऑल्सो बेस्ड ऑन प्रोबेबिलिटीज. सो यूल हैव टू फर्स्ट स्टडी डेटा पास्ट का. उसके बेसिस पे वी विल फॉर्म एक्सपेक्टेशंस फ्यूचर का. राइट? एवरीबडी फॉलोइंग दिस? And so this distribution is what we need to study right now. This is what we are trying to understand. यही probability distribution है. This is where eventually we'll move towards. Are you understanding why and what is probability distribution and why study this? Clear? यहाँ तक? ठीक है. Now, when you're looking at probability distributions, there are a few characteristics we need to understand. Either the distribution is discrete or it is continuous. Either the distribution is uniform or it is non-uniform. I'll make you write everything, just observe. Either the distribution is cumulative or it is non-cumulative. अभी क्या होगा, बुक में अगर आप definitions पढ़ना शुरू करोगे, discrete uniform distribution, continuous cumulative distribution. अभी प्रॉब्लम क्या है? How will you learn all the permutation combinations इस तरीके से? Now either the distribution is discrete or continuous, either the distribution is uniform or non-uniform, either the distribution is cumulative or non-cumulative. So a distribution can be continuous, uniform, non-cumulative. अगर आप इंडिविजुअली तीनों प्रॉपर्टी समझ जाओगे तो एनी कॉम्बिनेशन से आपको क्या डिस्ट्रीब्यूशन की बात बता रहे हैं, यू विल बी एबल टू अंडरस्टैंड, राइट? If I understand each of the properties, then I don't need to learn separately what is a continuous uniform cumulative or what is a discrete uniform cumulative. Are you understanding? So each of the distribution, like a company can be private or public, a company can be large or small, A company can be Indian or foreign. So एक company के multiple चीजों का characteristics होगा. So these are the characteristics of a distribution. So a distribution has to be either discrete or continuous. A distribution has to be either uniform or non-uniform, and the same distribution has to be either cumulative or non-cumulative. So we'll understand each of these properties individually first. Tell me, are you guys with me? So the first property is discrete or continuous. Discrete distribution, say for example, if I'm throwing a dice and 1, 2, 3, 4, 5, 6 outcomes are possible, and let's say इस axis पे क्या था, probability था कि data था? Probability था, इस axis पे data था. So possibilities are 1, 2, 3, 4, 5 and 6. Are there any more possibilities when you throw a dice? No. So probability is, let's say 1/6, 1/6, 1/6, 1/6, 1/6. क्या कोई भी probability 1 और 2 के बीच में हो सकता है? 1.5 का, 2.5 का, 2.2 का? They are finite countable outcomes. Finite है because infinite outcomes are not possible. Countable है, finite है obviously, and separate values है, इनके बीच में कोई values नहीं हो सकता. Now say for example, I want to plot another graph. Let's say I'm plotting the graph for rainfall. यहाँ dice का था question. Now when I'm trying to plot the rainfall, I've collected let's say last 5 years का data, 1500 some days or something, and उसके basis पे 0 centimeter से लेकर के it's going up to a maximum of 200 centimeters का rainfall. Let's say अभी centimeter का जो rainfall है वो इस तरीके से I have calculated and I have made this graph. Now please understand, isn't it possible? Now ऐसा है कि 110 सेंटीमीटर एक दिन हुआ, एक दिन 110.8 सेंटीमीटर हुआ, ठीक है. ये दोनों का probabilities are very high, right? So these are the rainfalls that have been recorded. 110 पे भी कई दिन हुआ, 110.8 पे भी कई दिन हुआ. Does that mean that a probability between 110 and 10.8 नहीं हो सकता? Is there a possibility कि rainfall will be 110.56 to 1? So basically, can you count the number of outcomes possible? You cannot count the number of outcomes possible. The rainfall, although I have not recorded anything between 110 and 110.8, but still 110.2914, whatever random number is possible. There are infinite outcomes possible. There are infinite outcomes possible in case of a rainfall. You cannot say कि या तो यही होगा या तो यही होगा, बीच का होने का कोई probability ही नहीं है. You cannot say so. This becomes a continuous distribution. There are infinite outcomes possible. What does the term discrete mean? ये discrete distribution है. देखिए discrete का दो meaning होता है, एक DISCRETE है और एक EET है. What do you understand by EET? Task. Then what is EET वाला discrete का meaning? क्या बोल रहे हो? छुप छुप के, secretively. You're being discreet about something. Be discreet about this. Don't tell anybody. Be very secretive about it. And ET is separate. ET जो यहाँ पे use कर रहे, that is separate. Please make sure your vocabulary is good, and you cannot be very bad at spellings and all. I've seen people making a mess out of spellings and all. You cannot do that. Your vocabulary, your spellings and all, ये सब खराब नहीं हो सकता. You have to start improving on these things. So discrete ET is separate. So when you are throwing a dice, you have separate, finite, countable outcomes. So या तो distribution discrete होगा, head tails, दो ही outcome possible है, finite है, countable है, या तो ये count कर सकते हो. But continuous distribution के case में there could be any possibilities between a given range. The range has been given to you over here, 0 centimeters to 200 centimeters, and the rainfall could be absolutely taking any value between that range. There are infinite possibilities between 0 to 200. 110.8921, whatever can happen, right? वैसे infinite मत सोचिए कि खाली 200 तक ही है, but number of possibilities तो infinite है. The number of possibilities for the outcomes, that is going to be infinite between 0 and 200 centimeters. Is everybody following this? So this is a continuous distribution, that one is a discrete distribution. This is a continuous distribution, and this one is a discrete distribution. Now when you are studying the discrete and continuous distribution, probability of any value is equal to 0. कैसे probability of any value is equal to 0? Because probability क्या होता है? Probability is equal to number of favorable outcomes by sample space, which could be any value, which could be any number divided by infinity, which has to be 0. क्योंकि यहाँ continuous infinite possibilities है, your sample space becomes infinite. Because there are infinite possibilities in this range, so your sample space is infinity. So even if 110 centimeters took place on, let's say, 250 days, still your probability of getting 110 centimeters का range is equal to 0. Because 250 divided by infinity is equal to 0, 250,000 भी होता, तो भी divide by 0 infinity is equals to 0. So the probability of any particular value, probability of any value is equal to 0. Are you understanding this? Now your next question would be कि अगर probability हर value का 0 है, जबकि वो 0 नहीं है, तो फायदा क्या है distribution पढ़कर? So if every single value, I am telling you that 110 centimeters is happening 250 times out of 1000 days का rainfall or a 1500 days का rainfall. It is a very sizable chunk, right? But still the probability of 110 centimeters का rainfall is equals to 0 because the sample space is 0. So in this situation what happens is that, say for example, this is 100 and this is 120. आपको अगर कोई का probability निकालना है, the probability can only be calculated for range. The probability of this range, the probability of getting a rainfall between 110 and 120 is the shaded region का area divided by total area under the curve. So probability value का 0 होगा, probability of any range, any given range is equal to area of shaded region by total area under the curve. Are you understanding this? Now you guys take down this. So 1, 2, 1, 2, and इस तरीके से और ग्राफ्स आएंगे. We'll be moving. I'll show you discrete uniform, discrete non-uniform, continuous uniform, continuous non-uniform. I'll do all pom-com for you. Sorry? Area कैसे infinity होगा? There has to be, I'll tell you, there has to be a highest value and lowest value. And उसके basis पे area तो एक curved enclosed area होगा ही ना? And even if you don't have a highest or lowest value, उसमें हम लोग normal distribution जब आएगा तब जाएंगे. Good. So his question was that whether will area भी तो infinity हो सकता है if this graph is tending that way. So उसका हम लोग normal distribution में discuss करेंगे. So yes, the area can be infinity, but then the challenge will be to find out कि अगर area infinity भी है तो आप इसका area as a proportion कैसे निकालोगे? We will see that later. Take this and also understand in practical life, in real life, आपका situation कैसा होगा? Will you have continuous type के distributions or discrete type के distributions? Continuous होने चाहिए. It is very difficult to say that stock का return will be either 8 or 8.5 or 9. It can be 8.5392%. It could be absolutely any random value, right? So it is not necessary that your values are going to be discrete in nature. So ideally we are going to be using more of continuous when we are working with sums and other areas. Take this quickly. And carry multiple color pens please class में. It's very easy when revision करोगे तब फायदा होगा. Under the curve, total area under the curve, area of the shaded region by total area under the curve. डिस्क्रीट का मतलब हो गया फाइनाइट काउंटेबल आउटकम्स है. एग्जॉस्टिव इवेंट्स आप हाथ में गिन पाओगे. There could be 5,000 possibilities, but there cannot be any 5,001th possibility. So you will be able to count 5,000 possibilities. Done.
Total area under the
Curve. Area of the shaded region by total area under the curve. Alright, now next one is your uniform and non-uniform distribution. So uniform, non-uniform basically means सारे outcomes का probability same या at least one of the outcomes का probability different. Now this becomes a uniform discrete. Discrete है वो अलग चीज है कि there are separate outcomes. Uniform in the sense that every single outcome, each outcome same probability. Say for example there is a dice जो corners से broken है, corners से टूटा हुआ है. In that case what happens, आप जब भी उसको थ्रो करते हो there is a higher probability कि या तो 4 आएगा या 6 आएगा, बाकी का probability कम हो गया. So now my distribution becomes 1, 2, 3, 4, 5, 6. Of course इनका probability 1, 6 नहीं है because total probability has to be equals to 1. So इनका probability अगर मैं 1/3 करता हूँ तो 2/3 इधर हो गया, 1/3 का 1/4 1/12. If you add up, you will get your probability equals to 1. 1/3, 1/3, 2/3 हुआ और 1/3 का 1/4 ये चारों है. That will be giving you a total of 1/4. Now this becomes a non-uniform discrete distribution. Uniform, non-uniform word समझिए. Uni single form, सारे outcome same probability, at least one outcome का भी different probability हुआ, so you cannot call the distribution to be uniform anymore. And when you're looking at a continuous distribution, so if I'm looking at something like this, that the value can range from 18 to 14 anything, इसके बीच में infinite probabilities है, but sub ranges, अब आप बोलेंगे कि ये तो फिर probability equal कैसे हुआ? 8 to 9 का probability, 9 to 10 का probability is the same. सेम विड्थ अगर लोगे तो उनका प्रोबेबिलिटी तो सेम आ रहा है. 8 to 10 का प्रोबेबिलिटी, 10 to 12 का प्रोबेबिलिटी, 9 to 11 का प्रोबेबिलिटी. व्हेन यू आर टेकिंग अ विड्थ ऑफ 2 और विड्थ ऑफ 1 और विड्थ ऑफ 3, द प्रोबेबिलिटीज विल बी द सेम. सो दिस बिकम्स यूनिफॉर्म एंड कंटिन्यूअस डिस्ट्रीब्यूशन. दिस इज अ नॉन यूनिफॉर्म continuous distribution. Making sense till here? Non-uniform continuous distribution. Why is it non-uniform? Symmetrical and non-uniform दो अलग अलग चीज है. Symmetrical मतलब average के ऊपर नीचे the probabilities are the same, the distribution is the same. But non-uniform means that इसका probability अलग, इसका probability अलग, and which is supposed to be true? Most of the data is not supposed to be having a uniform probability for all outcomes. There would be a higher probability around the average and lower probability as you move away from the average. That is how most of the data normally should be distributed. Making sense? Everyone? Sure? Take this. Graphs के साथ learn करना is much easier than to mug up definitions.
यूनिफॉर्म कंटिन्यूअस का एग्जांपल क्या हो?
Uniform continuous? No, practically I would not find anything that is uniform and continuous. I won't be able to think of an example. It's very impractical. Done? Uniform continuous is basically, so one you can see it's a straight line यहाँ पर. Values can be absolutely anything between these two ranges. So therefore it is continuous. अब आप 8 to 10 बोले, 10 to 12 बोले, 9 to 11 बोले, if you take the same width, उसका probability तो same आएगा ना, क्योंकि ये अगर straight line जैसा हो गया पूरा, it's like a slice, you know. So same width लोगे तब तो probability same आ रहा है. That is uniform continuous, right? मतलब practically I would not be able to think of a single example इसमें. So basically when you're looking at discrete and continuous, discrete continuous क्या था कि whether you have finite countable outcomes अलग अलग या you have continuous ranges, and uniform non-uniform is do they all have the same probability or they have at least one of the variables will have a different probability. That is your uniform non-uniform. Cumulative non-cumulative का difference क्या हुआ? Non-cumulative is basically ये सारा जो भी किए हम लोग अभी तक they are all non-cumulative. Cumulative मतलब यहाँ तक का probability. Non-cumulative is इस part का probability, इस particular variable का probability. Example, all these are non-cumulative. I will give you the cumulative version for each. So cumulative अगर इसका करना है, this is the cumulative, discrete, uniform. Why is it cumulative? 1 तक का probability 1/6, 1 तक का probability 1/6, 2 तक का probability 2/6, 3 तक का probability 3/6, 4 तक का probability 4/6, 5 तक का probability 5/6, and 6 तक का probability 6/6. Last one has to be equals to 1 if you've taken all the data. Cumulative मतलब यहाँ तक का probability. Cumulative probability would be 3 तक का probability is cumulative probability of 3, and 3 का probability is non-cumulative probability of 3. 3 का probability, 3 तक का probability, probability of 3, probability till 3. That's the difference between cumulative and non-cumulative. Cumulative, the term English term cumulative will tell you, accumulate करते हुए, add on करते हुए, यहाँ तक का probability total, that is cumulative. This one is non-cumulative. Now when you're looking at the first one, obviously the cumulative graph जितना भी होगा, it has to be upward sloping because you keep on adding the probabilities. It has to be upward sloping, there is no other way. इसका अगर cumulative करेंगे तो आपका ग्राफ इस तरीके का आएगा. Are you understanding? I need space, I need to make 2 more. तो यहाँ यूनिफॉर्म तरीके से ये नहीं ऊपर जा रहे ना, 1/6, 1/12, 2/12, 3/12, अचानक से 1/3 ऐड हो गया. सो ग्राफ इज गोइंग टू बी मेड दिस वे. ये भी क्यूमुलेटिव है, यहाँ तक का प्रोबेबिलिटी, यहाँ तक का प्रोबेबिलिटी, यहाँ तक का प्रोबेबिलिटी, यहाँ तक का प्रोबेबिलिटी. द जंप्स आर नॉट इवन The jumps are not even. You're not adding constant same value ऐड करोगे तब तो एकदम प्रॉपर यूनिफॉर्म स्टेयरकेस की तरह बढ़ेगा ना, लेकिन यहाँ पे तो कांस्टेंट वैल्यू ऐड नहीं करे हो, यहाँ पे एक बार बहुत बड़ा वैल्यू ऐड किए हो तो ये यूनिफॉर्म तरीके से नहीं इंक्रीज करेगा. सॉरी, आई गाइस फॉलोइंग दिस? These are the way of representing. So we'll see which graphs we are going to be using. We are going to sticking to this. We just need this one as we move forward. बाकी सारा भी पता होना पड़ेगा. You need to understand your basics well. But otherwise we are going to be using this everywhere. I'll come to that. Give me time. Sorry. Then when I'm looking at these two graphs, continuous वाले का, इसका ग्राफ तो एकदम irrelevant है. इसका अगर cumulative बनाऊंगा तो इस तरीके का बनेगा. Because you're adding constant value, probability 1 से मतलब जो भी probability as you're moving forward, you keep on adding and 1 खत्म हो जाएगा यहाँ पे. ये जहाँ पे आपका triangle खत्म हो रहा है, यहाँ 1 खत्म हो जाएगा आपका probability. You're continuously adding the same value. इसका वाला पे ध्यान दीजिएगा. इसका corresponding would be see, it is not sloping downwards. It is not sloping downwards. Why? And why is the shape like this when I'm talking about a cumulative, continuous, non-uniform? The idea is ये यहाँ का probability है, ये यहाँ का probability है, ये यहाँ का probability है. As you move forward in this direction, you add bigger values. So your slope is getting steeper. Then you start adding smaller values. Add तो कर ही रहे हो, smaller values add कर रहे हो, but add कर रहे हो. So it cannot slope downwards, but the slope it becomes flatter. And as it is going to tend towards infinity, एकदम minute हो जाएगा, तो ये almost flat हो जाएगा as you move forward. That is your cumulative continuous non-uniform. So if this is A, B, C, D, ये उसका corresponding A, B, C, D है. ये ABCD जो है ये नॉन क्यूमुलेटिव वर्जन है, वो ABCD जो है वो क्यूमुलेटिव वर्जन है. I'll give you 2 minutes, take it down, I'll again revise this part. हाँ, cumulative has to be, it has to be increasing, always increasing. Constant तब होगा जब 0 हो गया बाकी वेरिएबल्स का probability. ये constant कब होगा, flat कब होगा, जब और probability ऐड करने को बचा नहीं, when it has reached 1. You're adding continuously same value ना, तो slope तो constant रहेगा ना. Continuously 1 ऐड करेंगे तो 1 2 3 4 5 6 7 8 वैसे बढ़ेगा, because सबका probability same ऐड हो रहा है. That is why इस तरह का shape है. C is एकदम irrelevant, लेकिन you should understand, but it is absolutely irrelevant. D चाहिए हम लोग को खाली. We are going to be working with this. 99.99% जगह खाली ये काम आने वाला है. Sorry, final value has to be 1. Yes. The total cumulative probability once you reach towards the last value, it will be 1. आर वी गुड? यहां तक ठीक है? So basically we are looking at three characteristics. Either the distribution is discrete or uniform, discrete or continuous, or the distribution is uniform or non-uniform, or the distribution is cumulative or non-cumulative. तीनों अलग अलग properties define कर रहा है. So any distribution right now, if I tell you uniform, continuous, non-cumulative distribution, you should be able to answer. Uniform मतलब सारे probability same होंगे. Continuous मतलब any number of values between a given range is possible. Infinite possibilities are there. It's a continuous distribution, not a discrete वाला distribution. And non-cumulative मतलब उसका probability का बात कर रहा है, वहां तक का probability का बात नहीं कर रहा है. So discrete or continuous tells you discrete, separate outcomes, countable, finite outcomes, उनका individual probabilities define हो सकता है. When I'm looking at continuous distribution, any number of values within a given range is possible. That is what a continuous distribution means. In a continuous distribution, every single value will have a zero probability. Because कोई भी चीज का sample space is infinite, therefore the probability of any value, even though it is occurring a lot of times, still उसका probability zero है. तो continuous distribution में अगर आपको probability निकालना है, it has to be for a given range. So वो range का probability is a space, the area of the range divided by total area under the curve. Then your distribution can be either uniform or non-uniform. All the outcomes have got the same probability, uniform. At least एक भी outcome का अगर probability different हुआ, तो we cannot call it a uniform distribution. It becomes a non-uniform distribution. And the third one is cumulative or non-cumulative. That is यहाँ तक का probability is cumulative probabilities, and non-cumulative probability is that particular part का, that particular range का probability, not वहाँ तक का probability. 99.99% cases. Now what we are going to be working is with this one. That is non-uniform. Non-uniform, continuous. Non-uniform, because generally market में क्या होगा, variables continuous होंगे. You cannot say कि नहीं ये 5 ही value हो सकता है. Continuous के लिए बोल सकते हो शायद the tax rate could be something where you can say it is going to be a discrete variable. Either it's 25% or 30% or 35%. Although technically it can be absolutely anything, but still अपने बोल सकते हैं कि या तो कंपनी है तो 25 होगा, छोटा कंपनी है, बड़ा कंपनी है 30 होगा, ये होगा 35 होगा. Let's say, although bad example, but generally all the variables are going to be continuous. They will be non-uniform because there will be more probability around the average and less probability as you move towards the tails, towards the extreme values. And it is going to be non-cumulative because वहाँ तक का probability तो मैं बाद में निकाल सकता हूँ ना, मेरे को तो उन ranges, उन areas का probabilities लगेगा. So we will be working with non-cumulative distributions. हाँ, cumulative निकालना आना वो कैसे क्या होगा we'll see later. But this is the shape we are going to be working with the most. 99.99% cases we are working with this. Tell me, are you guys following this much? यहाँ तक ठीक है? Couple of very small things. Just a minute. Just a second, I'm forgetting a term or two, I guess. हाँ, लिखने का तरीका क्या होता है? Now, say for example, I'm taking a simple example, guys. I just want to explain something. Probability of getting a 4 is equal to 1/6. Cumulative probability इस तरीके से लिखते हैं. So this is x equals to 4 का probability. And this cumulative function is x less than equals to 4 तक का probability. This is going to be 4/6. So cumulative लिखने का तरीका ये है. Normal probability लिखने का तरीका ये है. If you want, you can just take an example of this one so that you know how do we denote the functions के names. बाकी you can apply it in multiple examples, it won't be a problem. ये खाली लिखने का तरीका और कुछ नहीं है. Okay till here? Understood the distributions basically? और भी टाइप का डिस्ट्रीब्यूशंस अपने करेंगे, बट दिस बेसिक्स ऑफ डिस्ट्रीब्यूशन एवरीबडी इज कंफर्टेबल विद. प्लीज मेक श्योर यू अंडरस्टैंड द थ्री प्रॉपर्टीज, एंड इफ एनीवेयर इट इज गिवन दिस कंटिन्यूअस, डिस्क्रीट, नॉन यूनिफॉर्म, क्यूमुलेटिव, तो आपको अपने आप समझ में आना चाहिए. कंटिन्यूअस का अलग मतलब, इसका अलग मतलब, इसका अलग मतलब. डोंट मग अप ऑल द डिस्ट्रीब्यूशंस, इट विल बी वेरी इरिटेटिंग. अंडरस्टैंड द कैरेक्टरिस्टिक्स, each of the three characteristics, either uniform, non-uniform, cumulative, non-cumulative, discrete, continuous. Understand each of them individually. ठीक है यहाँ तक?